Good afternoon, morning, potentially evening to everybody who's joining. Appreciate you taking the time. I'm joined by Lucrecia Gomez, who is the Program Area Lead for Frost & Sullivan's Energy Research. And today, the pair of us will be talking you through some of the things that we're seeing in the sector right now. 2025, I think it's fair to say, was a year of some turbulence at times within the sector. Most years have got some big events that tend to shake things up. I think obviously the US election at the end of 2024 was probably the biggest dynamic that impacted things both in the United States and outside of the United States in terms of power and energy. So we'll be touching on that topic certainly through the things that we cover today. Just to introduce Frost & Sullivan, we have around 30 offices around the world. We are more than 1,500 people across the globe. I'm based in London. Lucrecia is based in Buenos Aires, but we have a number of people across all continents. And we support clients basically with actionable insights to enable them to develop their growth strategies, be it through the subscription that Lucrecia and I deliver content for, or through bespoke advisory work for clients. Just to show the breadth of our coverage briefly, so we represent the energy and buildings practice. So we have three core areas within energy and buildings, but you can see across different industries, we have a larger number of practice areas. We have particularly substantial presence in ICT, in mobility, in healthcare and life sciences, amongst others. And just finally, in terms of specifically power and energy, our key focus of coverage within the space is really power and distributed energy. So all forms of generation, from the large nuclear power stations down to micro fuel cells. We cover all aspects of grid modernization and flexibility. So that is very much focused on a lot of the forecasting for the hardware, but also the software, the services, the solutions, particularly flexibility solutions, for example, that are becoming more important. And a substantial element within that, obviously, is the growth of battery storage, and we'll talk about some of these today. Critical power features a number of critical components that provide support to the power system. And data centers is a big use for a lot of these areas, but we do have our own dedicated data center infrastructure track within power and energy, representing the huge investment that we're seeing, obviously, in that space. So we look at the investment, the technology trend, the operator profiles, cooling, modularity, huge topics. And again, we'll be briefly touching on data centers here today. So with that, we're going to start off probably with we'll start off more at the bigger picture and probably go down to some more specific details, and we'll start a bit more on power generation first. This is our sort of latest projections for the investment that we expect to see across a range of different subsectors within power going forward. Lucrecia, maybe, you can talk us a little bit through this. Obviously, this is very, very big picture, but what do you think are some of the key messages that you'd take out of this?
Thank you, Jonathan. Well, as I said, the key message will be that near 1 trillion will be still included. This means basically that there is acceleration in the renewal terms, but we are also seeing that there is 916 investment in gas power generation and around 680 billion in coal fire, which means that the acceleration in renewals is also combined with acceleration in the use of gas. Now that we're seeing that basically in the use of turbines and hybrid systems, the combination with batteries, what we are seeing is that there is the need for flexibility in the systems and reliability of the systems, where that most of these investment is coming along from China and also from US, but Europe and Asia Pacific as well also complaining.
Okay, yeah, it's very interesting the amount we see there. I mean, another one is obviously, and we'll talk about it a little bit later, is nuclear as well. We've seen, over $1 trillion invested over the 15-year period in nuclear power as well. So I think across the board, we see huge numbers there. This gives an idea, just some of the regional splits, how we see that panning out. So I don't know if you want to comment on this. And it's interesting, I think, that investment does actually start to decline after 2030. So it would maybe suggest we are really at the peak of investment right now.
Yes, it does, but at the same time, it also shows the importance of the split between the investment. We at the beginning of the 24 and maybe before, as you said, the elections, we were thinking that natural gas and coal will be kind of declining faster and renewal will be accelerating, but we're seeing that the mix kind of remains. We're seeing the acceleration of renewals in mostly for US, China, and part of Europe. But Europe is more. But at the same time, we're also seeing growth percentage in gas use. As I said, this, and we will be talking about this later, this is because we need stability of the systems, and we are seeing that even when we are including more solar, wind, and in some cases hydro, we're not able to in the transmission lines. So there is a problem with the grids, and the stability of the systems needs load right now. So gas is proposing that. And so we're seeing the extension in the use of gas plants and some coal plants in some regions too.
Yeah, I think what I see here when I look at these, and actually if I look at the last two bars, which gives us sort of the 5-year time horizons out to 2040, India is quite resilient, and in India and South Asia is mainly India, not exclusively, but India is obviously a big part of that, and it's become more investment recently. But it's quite interesting that Indian investment looks fairly consistent through the whole time, whereas European EMEA investment, which is not just Europe, by the way, there's obviously a lot in the Middle East, definitely has a surge towards the end of the decade and then slightly declines. And I think, as you made the point, then China, very interestingly, is such huge investment levels now that the feeling is that probably won't be, that it just won't be necessary at the levels that we see going forward for a longer time frame. But we always know that China's quite hard to call. We move then to look at some of the fuels, and this is the annual addition. So we've taken it a slightly different way from the value to the additions coming online. So maybe you can comment a bit more on this. I mean, it's clear that solar remains very strong, but any other context you want to give?
Yes. Yeah, well, solar remains strong, as we said, but it's interesting to see that it's also a combination with other sources like wind, for example. We're seeing problems, for example, in US for offshore wind, but onshore wind it's growing, and we're seeing growth for hydro in Latin America, for example. So solar remains the strongest one, but all the other renewable sources are growing. And we are also, as I mentioned before, seeing gas remain very stable during the whole forecast. That's because we're seeing more the use of hybrid systems, combination maybe with solar and batteries, maybe even hybrid system with a combination of multiple renewable systems in the same power plants where they're able to use solar with wind. And in all cases, they're also now transitioning in the use of solar plus gas and batteries, or maybe wind plus gas.
It's interesting with gas. Sorry, yeah, I was just going to say it's interesting with gas because it does weaken in the very long term out to 2040, but for the sort of 5-6 year horizon into the 2030s, it's still very strong. It's fascinating to see that.
Yes, there is a combination there of, it's not only if we're talking here about new additions, but if we're also talking about investment on extending the life cycle of the current systems, that is another big revenue streams for gas. Right now, as I said, they need that systems to be flexible in order to be able to work with multiple fuels, and they also need some kind of stability. We know that, for example, US is having huge permitted issues, and this is delaying every new system coming online. So if you already have gas and you can extend the use of that, that makes system more reliable, and they also gives you the chance maybe to work around flexibility with the other systems in the end.
Yeah, we've got a question actually coming in about our offshore wind forecast. So the questioner is asking about our, we offshore. The question is essentially offshore wind is very challenging now, but you see it accelerating towards the end of the decade. Where do you see that activity happening? I can take that one. I mean, Europe, we certainly see, and it has been tough in Europe. There's no denying it. Costs shot up. We have seen delays to projects, but we are seeing things stabilizing and improving there now. And governments have reacted with incentive plans that help offshore wind to some extent. And it is a key part of decarbonisation for a lot of European countries. Obviously, a lot of European countries have sea borders. They have good conditions, basically, for wind. The UK, where I'm obviously based, we are doubling down a bit on offshore wind. We're having significant investment. France, Germany, a lot of big countries are putting in there. We still see growth from China, very, very suitable for essentially supplying power to the East Coast. So we see those as being, I guess the key growth points for the next 3, 4, 5 years. Beyond that, we do see more potential certainly coming in from, and it will be gradual, but we will see potential in East Asia certainly for offshore wind, some in Southeast Asia as well, and we may see a comeback in the United States as well with that, but it's very early to say that right now. Obviously, the policy is against it, but so on offshore wind, we do see there is project movement going forward. Maybe we turn to the United States then, Lucretia, and you can maybe talk a little bit about this. I mean, I think it's fair to say that things continue to move in the US almost as we speak. There is the suggestion of new tariffs obviously coming through and what that could mean, but maybe talk a bit about where you see the prospects for solar going forward in the US.
There is a strong prospect of solar. I mean, we are seeing around 60, maybe more gigawatts of capacity added in the next couple of years. So we also saw a strong 2025. Maybe not as strong as predicted at the beginning, but still around 30 gigawatts were added during 2025. We're waiting for the final numbers, but we will be seeing similar growth within the next couple of years. And of course, it will decline in the future, but until 2030, the growth of solar will be very important in US. There is also projections from CEA saying that there will be around 44 gigawatts installed in 2026. That includes not only utility capacity, but also commercial and industrial and some part of residential. These are kind of too optimistic right now, but still could reach that number. And we don't think it will be that high. We are more in the range of 30, 35 rather than 40, 45, but still. The major push that they have at the beginning of 2025 with the approval of the 7 billion programs came under question this year because they already utilized these decisions. So they are now having problems again with the small installations. So the growth will come around from the utility side rather than from the residential or commercial side. And we are also seeing that there is a diminution in new builds, especially because of what I was mentioning before, the combination between solar and batteries. That is also driving the market. It's not just solar that's growing. We will see later that the batteries market is strongly growing in US, and the combination of both systems is pushing for a great year in 2026. What are the problems with? Yeah, sorry.
No, no.
Yeah.
Sorry, I was just going to say. Just what I was going to make on the commercial industrial side for solar. It's interesting in the US. It's always been quite low. But like in Europe, in Germany, that sector really took off. But for some reason in the US, it's never done particularly well. But sorry, go on. Back to you for the headwinds.
Well, there is a discussion around that, whether this is not a system, a technology, or a cost issue right now. It seems to be a government issue right now if to push solar at residential or commercial level, if they kind of give the system more stability and rather than going back and forward with the decisions around the subsidies and support for the smaller scale projects or again at residential or commercial level, that maybe gives more guarantees in terms of growth. And in terms of challenges, well, as I said, there's multiple uncertainties around policy and trades. We have that credits, we don't have that credits. When is the year that it will end? And now we're having the discussion about new import restrictions and whether the court or the decisions about the old ones are going to stay or not. So all these problems around policies and uncertainties are making the market very hard to develop, especially again for big projects and smaller ones for the residential centers. In terms of the grant programs, as I mentioned, the policies changed at the beginning of the year, but we still have these made in USA programs that is basically supporting the supply chain, and some of them are in favor, some of them not so much. But what this program is creating is a problem around the equipment, because we know that made in USA cannot be done without the complete supply chain. And right now, the module part, it's okay. They have module capacity in US and it's very large. They are able to produce a CSA and around 44 gigawatt, but they still have the equipment for and then the fuel cells, and the precursor capacities. All these things are limiting the production, so they are ready in order to complete the model, but they are not ready in order of the equipment they need to do these models. So that will trigger a problem not only for 2026, but also for 2027, probably, if they don't resolve this issue rapidly.
Okay. So potential times ahead there. I'll talk briefly about Europe's effort to reindustrialize. Now, this is the EU has set some very sort of demanding targets for growing domestic manufacturing. I have to say, pace on this is pretty slow. So a lot of this was worked out in the last session of the European Parliament. So a lot of this was coming through in sort of 23 into 24. The reality is things remain quite difficult. Securing investment in Europe is still not easy for some of these products, particularly when you have got the much lower cost from China, makes it extremely difficult to shift away from that easily. I think there is more potential maybe in some of the higher value aspects of the sort of energy equipment. So I think things where it's more custom made, power transformers, for example, we still have a good presence in Europe, doing quite well. But I think on more commoditized equipment, it is very difficult, not just from China as well, but, India, there is growing investment there for manufacturing capacity. Turkey is part of the EU's customs union, so it avoids any of the tariffs or penalties. So I think it's going to be challenging for Europe to really gain momentum there, but obviously they feel they have to try. The next one I think we'll move on to, we'll talk a little bit about gas. So there's some big sort of dynamic forces impacting gas. I mean, from a European perspective, I'll speak first. Europe is still very much committed to its carbon goals, but these are difficult in the face of some challenges over industrial productivity. So it's going to be a bit of a balancing act for Europe. We are now largely we only now get a very small percentage of our gas from Russia. So that has been really reduced very, very low, and there's no plans to renegotiate any existing contracts that will run out. So in many ways, we've avoided the worst of the gas crisis that you might have thought a few years ago. A lot of LNG has come online that we've been able to take advantage of in Europe. That has helped us, but we still face the fact that our energy costs are relatively quite high, and we're still vulnerable to the fact that we are a major import nation for gas. And that does mean that our gas plants are generally utilized at a lower pace right now, because gas prices have been higher and supply has not been quite as good. And a lot of gas anyway is utilized more in sort of heavy industry. That's where we really need it within Europe. So I would say for Europe, we are, as I say, it's less of a headline issue than it was a few years ago, but there are still we're still looking to build up our security of supply a bit more. Lucretia, from a global context, how do you see things?
Well, in terms of global context, we're seeing a healthy market for natural gas, for sure, for liquid natural gas mostly. We're also seeing that the demand from US or the export from US are growing. And there is a new context that we need to consider. There is a relocation of some assets in Venezuela, and everything that's going there may change the map in the future, but it won't happen right away. I mean, it will happen in the next 2 to 3 years. And we are also noticing that the risk of oversupply in natural gas is not a reality right now. Most of the companies are diversifying their assets and not just focusing on exporting or producing natural gas. They are also they're also investing in other technologies. You see the portfolios is not full investment in natural gas right now. And in terms of use, we're also, and we mentioned this before, we're also seeing the extension of the life use of multiple natural gas plants. So the risk of oversupply in the market before 2030 is not becoming a reality right now. In the near future, we need to wait and see what will happen with Venezuela, and we don't have a new crisis in Europe or anywhere else. Where with the supply, the system seems to be consolidating. The participation of Japan in collaborating with Alaska, India, South Korea, and Taiwan are also pushing for long-term contracts and investment projects. So it seems to be more stabilized right now than it was a couple of years ago. So.
Okay, so we see things moving. I think moves us quite neatly onto data centers, and obviously we see huge investment in data centers right now globally. So we have basically 500 billion invested in data centers in 2025. Our estimation is that by 2035 we'll be looking at 1.5 trillion, so a factor of increase of 3, essentially. There's a number of things obviously driving that I think are very well known. But I think what is interesting, and why I made the link with gas, is obviously the power needs for data centers are quite considerable, and particularly in the United States, not exclusively, but I know the United States is the key focus. There is a tightness in supply. So how do you see things evolving in terms of the power needs of data centers? And I think the next slide probably will help us tell that story. So over to you.
Yes, well, as you said, there are multiple projections discussing how much will increase the consumption in the energy consumption because of the use of AI and in data centers. So we're seeing that from 2020 to 2030, a projection will be 210% rise in electricity demand, which is huge, of course. And we're also seeing a trend in data centers that they're using gas turbines to deploy more temporary prime power. They're using hybrid grid connected assets. They're also using behind the meter generation is raising fast in there. So, but in terms of gas, they use that the data centers are with the the turbines is interesting because they are using hybrid systems. They are using systems and reciprocating engines in parallel. Now there are multiple announcements about 400 or 300 megawatts new plants built just for data centers, and that goes to the chart in the right hand, where we're saying that the on-site generation will change up to 30%, maybe, or near 30% by the end of 2030. We started in 2024 with a projection of less than 5% was on-site generation for data centers, and now we're saying that it will go up to 30. So data center is not only using power, it's also driving the deployment of power and how it will be used. I mean, they need, and we all know that they need a stability of the system. They need to be reliable for them. So they cannot wait until all the discussion around permits, interconnections, all the problems that it's having with the transmission and distribution systems in US take nickel. So they are all producing their own site power. And most of this power is right now is coming from gas. We know that we're seeing multiple announcements from data centers that they are saying that they're also using nuclear. Of course they are. They're also using on solar. But at the end of the day, if you go to the hyperscalers, all of them are using this new renewable system combined with gas. So for the projection that we were seeing for gas, this needs to be considered. How much of that will go into data centers and how much consumption the data centers need in the next 5 to 10 years. Again, the projections are here, but maybe we are coming short.
Yeah, but I mean, it's going to be fascinating to follow. We have a lot of data center coverage, and this is an element that we'll be exploring, I know, more this year. To talk about, you mentioned nuclear power, we've actually been updating these numbers. These are our previous numbers, but it doesn't tend to shift too dramatically. We are seeing certainly some significant additions now. Obviously, you know, in the scale of solar additions, 9-10 gigawatts is hardly anything. But of course, nuclear is a baseload power source, and therefore it can provide significantly more electricity for the amount of capacity. I think what's also interesting as well, and our new projections out to 2040 would probably show this even more. While China is important, we are seeing more investment in the mid-longer term coming in other markets as well. So the way that we account for it, obviously this is capacity coming online. So a lot of the things you see in the 2030s are based on decisions being made now. And because of a desire for greater energy security, we have seen things moving forward more in Europe than we would have done a few years ago. And small modular reactors coming up in Canada, the US, amongst others. So assuming that industry can get ahead, then we will see nuclear certainly ticking upwards. From a European perspective, there's been quite a bit of activity right now. The devil is very much in the detail of them actually going ahead, but there are certainly a number of countries where they are looking to proceed. I would say the Czech Republic, Sweden, the UK, probably France are probably the most serious, I would say, in making progress. France is already a nuclear state. The UK has existing nuclear plants and has a big Rolls-Royce is very prominently featuring in this. The Czech Republic has signed an agreement with Rolls-Royce. The big utility there's taken a stake in that operation, which is quite significant. And Sweden, which already has nuclear power, has certainly the government there, and attitudes have moved a lot more pro-nuclear. So there's quite a lot happening on the small modular reactor front. I would just say, though, that these things do take time. And probably one of the pivotal things is going to be what happens in North America as well. So Bill Gates is supporting TerraPower, which is building a plant in Wyoming. And Hitachi are looking to build one in Canada as well. And that's getting underway soon. Now, the question is going to be ultimately how these progress and what the cost profiles are. What small modular needs is a couple of big win success stories where things don't overrun, where they can demonstrate that things happen reasonably effectively, and where they can really scale this up. Now, if that goes the other way, we our forecasts could well be out the window. But there is certainly more traction in small modular than there has been for a while, albeit paced fairly slow. I want to move on to, sorry, go on. Yeah, if you've got anything to say on nuclear.
Yeah, sorry, just to mention, as you say, there is more traction on the small reactor rather than in big ones, because you only see in life extension programs, not new builds in big power nuclear power plants. But for small reactors, we're also seeing North America is making an agreement with Argentina in order to the export of Argentinian small nuclear reactors. So it's not only produced in the US, but they are also considering importing from other regions as well. So that makes the idea that the market is going to grow in the near future for US. Again, a smaller one, not the bigger one.
Thank you very much. Now, if we think of storage, Lucretia already mentioned strong growth here. This is our sort of storage universe. I've used this quite a lot. Basically, the energy storage situation has moved from being really grid support to ancillary services now into being use cases that are spread across renewable integration, guaranteeing supply, helping end users avoid higher demand charges and costs, and then wider grid system support. There's definitely strong growth for storage overall across different areas. So you can see here, again, a bit more some of the different use cases and timing. And what we're also starting to see is longer duration for energy storage as well. So historically, a lot of the assets were considered for maybe up to an hour. You were really talking about frequency response, voltage support. It was more focused around minutes. We're now starting to see more systems being deployed with higher duration storage. So more focus on looking at 2, 3, 4 hours. And we're also starting to see more movement on longer duration storage. So the famous duck curve in California, it was really the base of this, the idea that essentially you have too much electricity being produced for a prolonged period and you need to use that later on. But certainly in Europe, it doesn't feel like it right now because it's been it's been quite a windy winter, but it hasn't been very sunny. But there are definitely times in Europe now, if I think particularly Germany as an example, where you can go from 10 in the morning to 6, 5 in the evening, where you have an excess really of solar power. And storing that and being able to utilize it in the evening will become more and more important. So reaching very long duration storage is going to be quite challenging, but some of these sort of early long duration things that will take days output and in the evening is certainly going to be very relevant. And it's a big growth area. So we're looking, latest projections, probably heading for around nearly 400 billion by 2035. That's up from 83 billion in 2025. That's up from 50 billion in 24. That's 20 billion in 2021. I mean, the growth has been very, very significant. It is mainly around grid. Grid is the biggest part of it, but you'll see that commercial industrial will really gain some momentum post 2030, and there's still a decent slice on the residential side as well. So we are seeing more attachment of solar PV systems being sold with storage systems. In the case of residential, we're starting to see some retrofitting of existing systems with storage, existing PV with storage, and we are seeing large-scale grid projects underway. So big growth there. And on the other side, we are seeing the battery pack prices continuing to decline. So China is the cheapest. Europe and North America is obviously more expensive. But we have seen, after a bit of a leap in 2022, we're now seeing the supply chain for batteries coming through. So again, we are quite dependent on China right now. So it's going to be interesting how this pans out, and this will potentially slow some of the reductions further, depending where they're being deployed. But it's quite a healthy scenario right now. And this is just an idea. I won't really stop on this. Just some of the big markets globally and where the installations are. As I say, we've been working on updates of these, but obviously China, the US, and Europe are the big ones right now. Right, we're nearly done. A couple of things near the end that I wanted to draw attention to briefly. Grid enhancing technologies. We've spoken a little bit about the grid. There is lots of investment going into conventional grid infrastructure, so cabling, transformer, switchgear, to expand the network and to upgrade the existing network. But there are certainly technologies that can be deployed to make it operate more efficiently. So a few that I'm just showing here. A good example, dynamic line ratings, again, has not fully taken off yet, but this is really where you deploy more sensors in the grid, and effectively you can improve the amount of capacity that's being transmitted over a network. So again, mitigating the need to build quite so much in terms of new cables and new projects. Equally, both power flow controls and topology optimization at the heart are fundamentally about redirecting power away from congested areas into other areas where there might be grid capacity. And these sort of technologies are going to become more important because with the penetration of distributed energy resources, we are having more pockets of the grid that are particularly busy and potentially overloaded. So if you think of it, for example, take a city, the suburbs are where you're more likely to have significant deployments of solar PV. You may also have households that are a bit more likely to have cars and will start to have electric vehicles. All of this is manageable. You can have storage systems with all of this as well, but this is creating slightly more volatility potentially on the grid. You're having more power being transmitted in some of these localized distribution grids, and that's where these kind of solutions can become very relevant. So they can be deployed at a relatively micro distribution level, or you can see them deployed at a wider distribution scale level as well, and in some cases in transmission level. So these are things that we'll be looking at a little bit more this year. Another aspect is conductor materials. So you essentially at the moment, 95% of grids are based on aluminium or steel conductors. Reconductoring is basically replacing these with carbon fiber, and you can increase the amount that can be conducted as a result. So you can basically remove a bottleneck that is in place, and you can actually get more power through the same network. You can also do this through superconductors as well. That's another solution that's being trialed and developed right now. But there are utilities that are starting to use these and to deploy this more. And all of this is basically saying we still need to invest, but we maybe don't need to invest quite as much. And these are other ways that we can achieve more effective management of the grid. Just briefly, virtual power plants. I think these are going to be relevant. They've been around for a little while. I think the uptake has been gradual, but with distributed energy growth, we are going to see these more and more, and we are going to see them a bit more at a commercial industrial level as well. So this will be, and it's very much dependent on the incentives for particular countries, but this is basically another way of reducing the burden on distribution network operators and transmission operators by enabling greater flexibility in the energy system, whereby you can combine these disparate assets, and then this can be basically they can be used to help the grid function more effectively. We've seen a lot of the VPPs have become part of utilities, so we are seeing some consolidation there. Effectively, it's becoming a part of a utility proposition to have this kind of software. And certainly in Europe, we're seeing more growth, and in parts of North America, we will see it as well too. Okay, this brings us to the end of the presentation. Just a few key takeaways to wrap up. So I'll take the first couple, and Lucretia, you can then maybe talk about data centers and the grid. But yeah, just to say, the pace of renewable growth really is largely being maintained. There are some bumps in the road for offshore wind. I think we've seen it recently, but in general, you're looking at solid amounts going in year on year globally into renewables, and you're looking at the penetration of renewables climbing ever upwards. So, whatever some of the headlines are, and there is always a mix of slightly more negative commentary and positive commentary, there's no getting away from the fact that we now get around a third of our power from renewable sources globally, and we will be looking at, by our estimations, two-thirds of it will come from renewables within 15 years, which is probably slightly lower than we might have said a few years ago. So we have slightly tempered our forecast, but we're still looking at nearly two-thirds. And in some of the advanced economies, we are looking at 80 to 90%. So there is significant amounts from renewable there, which is going to mean helping to drive strong growth in batteries to back up this renewables, to store it, to make sure that we can utilize it. Does also mean, though, there's a role for gas, because we will need something to help balance those times when we simply haven't got enough wind or sun coming through. So there's not going to be loads of times like that, but it means that there will be incentivization for gas, probably to be utilized less hours, but certainly it will be needed. Lucretia, over to the last two for you.
Thank you. Yes. Well, we were discussing the data centers' role in the systems, and we know that the demand for electricity will increase rapidly because of the data centers' consumption, but we also need to understand that they are becoming not just a user, that maybe are now a planner. They're kind of the new utility in the systems, because they are setting up the stage for which kind of technology we will be using in the near future in order to generate load. They are becoming the competitors of the grids right now. And this is something that everyone needs to consider, because the numbers for electricity consumption coming around from data centers in US and now in other regions as well is going exponential in the last couple of years, and it will keep growing in the next 2 years at least, if not even more. And the other thing in terms of, and this is connected with the progress and the urgent need to increase the grid investments and in order to create a better supply chain situation, but also to improve the flexibility of the grids. We know that the grids now is coming with problems with not only interconnections, but also with transmission issues. And they are using multiple systems. They have to increase flexibility. They are using renewables. They are using nuclear in some cases. And they have the technology. So the questions is now around why they're not increasing the investment. If this is a government issue in some cases, because there are not enough support in order to prove these investments, or it's also a culture around the utilities that they kind of choose fixing the small problems using these new softwares, or for investing or doing investments in transmission and distribution systems. So this is something that we will be also considering during the reports that we are producing this year, the flexibility of the systems and the grid investment projections.
Super. Thank you, Lucretia. I think we're largely wrapped up.